Okay, hello pre-calc classes. Today we are going to finish the last section of Unit 2D, which is creating those logarithmic regressions using the data, real-world data. Okay, so our essential question for today is how do I create a logarithmic regression model? This shouldn't be that different or new to you guys because we have been using our graphing calculators to create these regression models all year long. It's basically the exact same process, only now we have to know how to use the natural log as our regression model, not our linear, not exponential, quadratic, things like that. Okay? So if you recall back to earlier in Unit 2, we reviewed and saw a lot of log functions, So the graph that's given here in between the average salary for church pastors across the United States increases as the size of the church increases. By the looks of it, we should see that it does represent a logarithmic function. Okay, but just to refresh our memories, remember here, we are told or we discovered that the output values in order to see this in a table view, we need the input values to be changing proportionately over equal length output intervals. That's going to be a log model. Okay, so again, we need to be multiplying our x values or our input values by a same number over and over again, while our output values are adding or subtracting the same value. So that's what we should look for a log function. That's in a table. The graph has that scoop. That's either scooping up, or if it's reflected over the x-axis, it kind of scoops down. But you'll always have that vertical asymptote for a log model. Okay? So let's take a look at example 1. I'll review, like I said, nothing much new, but it says that that table represents a log function where we are told that L of x is equal to a plus b to the natural log of x. This is important to know because to use our graphing calculators, that is the only log function that we can actually assess. We can't use a common log base 10. We can't use a log base 2. So if you're ever asked to find a regression model using a different form other than the natural log, you won't be able to use your graphing calculator. Fortunately for our class, we won't have to do that, but there are other ways you can use systems of equations to help you find that, but we will not be asked to do that. We will only be asked to use the natural log, okay? So part A says to write 2 equations to help us prepare and set us up to solve this if we had to use a system of equation. So we've seen this type of question before. I have 2 input-output value combos. So the first one is when the input is 2, the output is 3. So I am going to plug those values into my equation. So when the output, which is L of x, is 3, that's going to be equal to a plus b times the natural log of my input value is 2. So I'm just taking those 2 values and plugging it into the equation that I am given for the input of x and the output of L of x. Now I'm going to do the exact same thing with my other input-output combo, which is 5 and 7. So when L of x is 7, that's going to have to be equal to a plus b times the natural log of, in this case, the input is 5. So if we had to use a system of equations, that's the route that we would take. And we could use that to solve one of the equations for A, substitute it into the other equation to be able to solve for B, use linear combination, even graph it if we wanted to. But those are the different techniques, okay? Like I said, fortunate for us, we don't have to do that. All we have to do is use our graphing calculator. So let's go ahead and get that out. So what I want you to do is, if you recall, to use a regression model, we need to enter this table into our calculator. So you go to Stat. Once you're at Stat, we start by clicking the Edit button, and then you can go ahead and enter those values that you see for the input and the output. Remember, keep in mind what you're calling your X's and what you're calling your Y's or your input output, because when we calculate the regression model, we need to tell our calculator what are our inputs and what are our outputs. Once you have those values in your calculator, then we go back to Stat, click the Stat button again. This time we need to click Edit or Calc at the top, not Edit. We need to be in the Calc, and then you can scroll down and see all your different options. One of them is, and in mine, if you're using the graphing calculator on your iPad, that is 0, and it's the natural log regression. So if you click that, you will notice that you get those same lists. Where do you want your X list, your Y list, and so forth. So I always tell you guys to put your X's or inputs in L1, your outputs in L2, so you should never have to change that. But we do want to store that equation in one of our Y's. So again, to do that, you go to vars, Y vars at the top, and then you click your Y1. I'm going to delete that because I only want one of them. And then we just we press our calculate button. So you will notice that we should get our A value of negative 0.026 approximately, rounded to the nearest thousandths, of course. And then our B value should be approximately 4.365. So now that we have that equation stored in our calculator, we would be able to answer any questions. What would be the value of L of X if X is 10? Or what will X be when L of X is 50? Things like that, okay? So go ahead, pause the video, and go enter this new table for example 2, which talks about that same example as we had up above, the church size and then the average salary in thousands of dollars, of course. But go ahead and enter that into your graphing calculator so that we can go ahead and run the regression model. And you will notice we are fortunate enough that this regression model, S of P, is also in that form, A plus B to the natural log of P, which is exactly what our calculator gives us. And that's the only one that our calculator will give us, okay? So go ahead, pause, enter that table of values, and then try to run the natural log regression. And once you think you're ready, go ahead and press play to check your work with me. Okay, hopefully you were able to run that regression. Now I did go ahead and enter that information into my calculator before making this video. I made mine in L5 and L6, so when I calculate, I'm going to change those values. You should probably have typed over L1 and L2, so all of your values should be right here for my X values, or for my input values should be right here in L1, and my output value should be right here in L2, okay? So when I go to calculate, I'm going to calculate the natural regression again. I'm going to change it to L5 and L6. Like I said, you guys should not. You should be exactly L1 and L2 again. And then let's just go ahead and let's try that. For my Y vars, I'm going to store that in my Y1. And because I have that value there, I'm going to delete that. And now I should be able to run it and get this negative 91.542 approximately. And then my B value should be 29.909 times the natural log of P, okay? So this is what I'm talking about now, being able to use that equation to help us find values such as what will be the salary, the predicted annual salary for a church size of 500 people. So go ahead, pause the video, and try to answer that question. Okay, perfect. Hopefully you were able to do this and you got 94,330. Now, you might be asking yourself, well, why do you have the 94,000? Well, that's because, remember, this is in thousands. So when we go ahead and use our var, our Y1 of 500, because that's the input value, so we're going to plug in 500 into all the input values, or P in this case, you should get 94.330, but that's in thousands of dollars. So then we need to change that and write that the average salary would be expected to be 94,330. Okay? Okay, let's take a look at one more example. Example 3 says, the most common and preferred method to measure sound intensity levels is in decibels. The sound intensity level, beta, in decibels of a sound having intensity of I in watts per meter squared is modeled by the function B of I is equal to A times B times the natural log of that intensity. So, where A and B are constants, if we are told that the sound of a noisy traffic has an intensity of 1 times 10 to the 5th power watts per meter, and it corresponds to a decibel level of 70, that's giving us one ordered pair, 1 point or one value in our table. Then we're also told that a loud concert has an intensity of 1 and corresponds to 120 decibels. So if we think about this in terms of our equation, ask yourself what's the input values and what are the output values. And based on what I'm reading in this equation, I should be able to say that the intensity level is the input values because that is what is my x. That's what the equation is working off of. You need to know the intensity level to be able to find the decibel level. So if I is my input value, then I'm going to just go ahead and make a table of values. I was told that when the intensity is 1 times 10 to the negative 5th power, the decibel level is 70, and I was told a second point that when the intensity level is 1, the decibel level is 120. So that's my table. It's exactly like example 1 and 2 now. I just had to think a little bit more about it to be able to identify what are my inputs, what are my outputs. They're giving me 2 ordered pairs and just put it in table form. Go ahead, pause this video then. Enter that into your L1 and L2 so that you can go ahead and run your regression model for your intensity level, your decibel level. Okay, hopefully you were able to do this. So if we were writing 2 equations, I would just go ahead like I did example 1a and plug in the 70 for my output when my input is 1 times 10 to the negative 5th power. And then for my second equation, I would plug in 120 for my output when 1 is the intensity level. Now this one would be real easy to solve because if you recall, that natural log of 1, that's e to what power is equal to 1? And we should know at this point that that's the same thing as 0. I would go ahead and change that to 0, and anything times 0 is going to be 0. So that natural log of 1 wipes that b out completely, telling me that my a value is 120. And then I could go ahead and plug 120 into the other equation to be able to solve for that b. That's how you would do it, like the algebraic technique, like I was saying, with kind of a system of equations. But because we get to use our calculator, then we can go ahead and just enter those values in. So when you entered those values in and you ran your natural log regression model, you should have gotten that a is the 120 that I just talked about, and that b is approximately 4.343. Okay? Now, go ahead, press pause, read through C, and use that regression model that we just came up with in part B to then determine what they're asking in part C. Okay, hopefully you were able to identify that they are giving us the intensity level. What value was the intensity level again? That's right, that was the input value. So I am trying to find out where what the decibel level would be if the intensity level is 1 times 10 to the 4th. So I absolutely would plug in 1 times 10 to the 4th for my I value, and then that will tell me what my decibel level is. And in this example, that should be about 160 decibels. Okay, that's what's going to be to burst, that's what it's going to need to take to burst the human eardrum. Okay, hopefully that was a good review. Like I said, not a whole lot new, good refresher, good review of some of the key concepts for logs, and then also how to use that graphing calculator to be able to run those regression models. So go ahead and work on your homework. If you have any questions, let me know. But that should do it for Unit 2D now, okay? So get ready for our summative.